topic has appeared, like security problems. Yeah. Okay, let's start.
Микрофон, по-моему, не включен.
Okay, so in this part, we will talk about how we develop, what problem we encounter, etc. And it is a collection of maybe not really connected together topics, just to look from different sides. And first part is security problems that we solve. And in this part, it's external security problems that we solve with our product, with the features that we build, and this is why we build them inside. So one issue is legacy protocols or old protocols like SNMP version 1, SNMP version 2, Modbus, Ethernet IP, MQTT to some degree. They were designed with maybe simplicity in mind and not with security in mind, especially if we talk about Modbus, for example. Basically, Modbus allows you to full control over the device. You can read device registers, you can write device registers. You only need ability to connect. So if it's a Modbus TCP, you connect to the device. If it's Modbus over serial, usually you have your gateway that again will allow you to connect to all devices behind that gateway, no questions asked. No encryption, of course. So anybody who could tap into your network can capture Modbus traffic as an MP version 1, version 2 traffic, Ethernet IP traffic, MQTT traffic if you did not configure encryption. And it's really common to have MQTT traffic running without any encryption and authentication because it's simple. So for that reason, we added the proxy agent functionality to minimize the area where old unencrypted protocols actually transmitted. So you put NetXMS agent as close as possible to your devices that only can be monitored using those old protocols. And then agent keeps connection to this NetXMS server over encrypted and authenticated protocol. And it acts as a proxy. So all SNMP requests, all Modbus requests just tunneled through the TLS encrypted connection to the agent, and only this last hop from agent to device, you have your protocol in clear text. And agent itself is much more secure. So as I mentioned, the connection between agent and server always encrypted. You have to explicitly allow IP addresses from where connection to agent is possible. So you have to list them one by one. There is option to list the subnet, but it's of course could be only used for testing, and it's not for production use. You have an option to use TLS connection with certificate-based authentication. So both agent and server authenticate each other using TLS certificates. And everything is within that single connection. It's very firewall friendly. You only need just one TCP port in either direction between agent and the server. So it's possible that server connects to the agent, or it's possible that agent connects to the server. In both scenarios, single TCP port is enough. And because it's possible for connection from agent to the server, agent does not need a fixed IP address. So you can have, I don't know, GSM gateway and agent behind GSM gateway, or write on this GSM gateway. and it can change IP addresses, and it still will work fine. So this is a simple picture that we isolate those insecure protocols within the very local network, and then we use secure connection to the outside. Another part of the story is that there should be security inside application. And what we do for that? First of all, we have very granular access within application. As I mentioned in the first part, you can configure different access rights. We have like maybe 15 different access rights that you can configure on your objects. And it's hierarchical, so you can give access to single device, you can give access to the group of the devices, etc. And you control very granularly who can do what. We support two-factor authentication for the users. Could be authenticator application like TOTP, any TOTP application. It can be one-time passwords that are generated and delivered via, Telegram or Slack or something. We support external authentications via LDAP and via radios. So if you have your big IT infrastructure with all the security requirements for passwords, maybe two-factor authentication as well, you can just use this and don't use internal database of the NetXMS. The typical usage scenario, many organizations have Microsoft Active Directory, and you can integrate NetXMS with Microsoft Active Directory via LDAP. And an additional benefit is that users do not need to remember additional logins, additional passwords. They just use the Active Directory login and password for connecting to NetXMS. You have to mask passwords in logs. We are not 100% there yet. On high debug levels, you still can get some passwords from time to time in NetXMS logs, but again, for hardening the system for production run, you should not run it on a high debug level logging. You should keep debug level at minimum. Passwords are hidden in a user interface, so because we have a lot of places where you should enter, SSH password or SNMP community string and stuff like that. It's all hidden. We also have an option for configuration files to obfuscate passwords. So you obfuscate password with a special tool, and you put obfuscated password in the configuration file, so that if somebody reads it, just not read, but just glance at your screen, for example, when you're editing the configuration file of the server, it will not be able to quickly read and remember the password to the database, for example. Secure communications, which we kind of related to the proxy, but not only for the proxy. So all communication channels are encrypted. When you connect with the GUI application to the server, it also uses encrypted protocols. A single TCP port for the server to agent connection, as I mentioned already. Certificate-based authentication. By the way, it's also possible to authenticate users by certificates, for example, on your hardware token. Control IP addresses where connections are allowed on the server, on the agent. For the web UI, because it's usually the most open part of your system, it can be hosted on the separate server that can be located in a different network. and only allowed a single TCP port from web server to the core NetXMS server for communication. So if somebody gets access to the actual web server, it will not get access to everything. It will only have that same client port open from web server to the NetXMS server, but nothing more. So that was a little bit about security, and now Tanya will talk about our development process.
Yeah, we're doing this presentation first time. Usually we talk about the product or we talk about how to add some extensions to our product. Now it's about our development. So you can see how we prepare for the releases. So we have just a whiteboard with a plan, what should we include. And as you can see, there are some like normally written lines, and sometimes we just squeeze some bug fixes inside because you may plan as many as you wish, but it never goes with the plan. So we usually have a big plan for some major release, and we have some plans about bug fixes. Usually it's not plans. Usually when something broken, we are just working with the broken stuff and then continue with new implementations. Some stuff we need to plan ahead for multiple releases. When we need to change something that might broke the system, we try to do it in the steps so that the user don't need to change all the stuff, and we like introduce step by step in different releases. Our system goals were and are that it is cross-platform. We have a lot of platforms where we develop, we should test. We have it's the same code, but it might be different code blocks. We should test it on all platforms that we have. So we have about 20 of them on which we're testing. We have performance in mind. So as I said, like when every new client with like huge implementation comes, not every, but like sometimes there come new implementations, and we see some bottlenecks that we should fix and that we face, and sometimes it's not really obvious. For example, when there was extends and XSL usage, our script usage, there was a problem that we were allocating and deallocating a lot of memory in C++. And yeah, like we thought that maybe it's somewhere else, but at the end we found that we should write like our own small memory management to work it quickly. Also, scalability, also related to performance, and that we should be able to support really huge networks. Sometimes it's a small network, but really a lot of metrics. We also talked about this low profile agent. It's exactly like that. We think that you should be able to run agent on a drone if you want, if you need to. You also can run a server on Raspberry Pi. It compiles really slow, but it runs. You can use SQLite as a database. It's totally not recommended for production, but for home installations, people use this solution. Do I have something to add? No? Okay. So our major design decisions connected to the previous slides. So we use caching to decrease load of monitored systems. For example, we have web service monitoring, and Oracle, one of the clients came and said that, okay, I can collect all the data from the Oracle web service monitoring, but it does not perform well, and it feels really bad because there are tables and we want to collect not the table but the metric. We can collect tables, but it's harder to work with them. So can you do something with this? So we developed web services, web service provider. We have there some credentials, stuff like that to authenticate. And then we have their metrics for how long should we cache the data. So you collect the data once, for example, per minute or once per 10 minutes. It depends on how good your web service is. And then you are able to collect already metric inside of the NetXMS from this cache data. So it doesn't add the load to the system. And this web services is not the only point where we use it. We use it really a lot because sometimes like you want multiple servers to collect the same data from the same agent once per second, and you can imagine how big load will it be. So you just cache this data and provide the last known value. Next one, use queues to separate data collection from data reading and from data writing. What is the problem? From the network, from the agent, there might come a lot of data, and it might come in the small period of time, and its processing might be a bit slower than data is coming, like not all the time, but like in this exact moment. So we have a lot of queues where we get the data, we put it in the queue process the data. Then we put it to the next queue that writes this data to the database. Because, yeah, again, database writing might be really slow. And also it might be much faster to write to the database the big blocks of the data. Why should we write each line separately if we can just make big SQL statements? So products should be extendable. As you heard, it's exactly about these notification channel drivers, about subagents, about SNMP drivers, and we have like a lot other stuff that can be added to the system without changing the system itself. When the client comes, or sometimes we have exactly this development trainings when we talk how to write all those parts, how to add to the system. So we need a really clear API that contains all the stuff. Still, for the notification drivers, SNMP drivers, and subagents, you should write in C, C++. I think it's the main stopper for many people to write the code. Usually you know this language good. Like we are working on it. We are thinking about other options, which languages we can provide for those purposes, and how it should look like for other contributors and for other developers to be able easily adjust the system, extend the system. Internal scripting language. As we already mentioned, it is used extensively. We're using it everywhere through the system, and it gives the end user a lot of flexibility. So it's like one of our solutions, how to give user option to script something that is not yet in the system, but it's also required really good planning and like implementation. Yeah, that maybe Victor can later tell more about scripting. Yeah. Okay, and smart agents that can offload some tasks from the server. It's important point in case of the design where we put implementation of the logic, because we can put everything in the server and server collects all the data. But if one site or like one networks lose the connection, then agent can't do anything by themselves because he doesn't have this implementation. So that's why we use extensively sub-agents, which each sub-agent implements its own logic. For example, we have sub-agent for Mongo monitoring. We have sub-agent for this different database monitorings. We have sub-agent for, I don't know, UPS monitoring. So yeah, and every time we're thinking about adding new functionality, every time we come to the point that, okay, agent should be able to collect this data by himself because we need this caching functionality when the network goes down. Also, another point is that if you have really huge network and you can imagine how many connections should make server to all those devices to collect all this data. So you can spread your network through different zones. Each zone has multiple proxies. Those proxies already do the collection, so they connect to those devices, they collect this information, and they provide already with a single or like multiple connections, but like from one node to the server. And also, they are capable of load balancing between each other, and they are also recently we have implemented that they are capable of load balancing when the network goes down. So they have this heartbeat checking that all the proxies that we have are up, and when some of the like any of those proxies go down, other proxies divide the load that was put it on this node between them all. So yeah, so the idea is that each of them has some data collection items that they collect, and then one goes off. Those data collections are separated to those that are still up. Do you have something to add? Okay. Versioning. Very important part. You should have versioning, especially if you are giving your product to end users, because if you like have last version, very last version, very, very last version, as you usually have in emails when you have presentation going back and forth, then you just can't really get like what version has this issue and what have changed. And when you already work with users, like they complain about the bug and you know that, okay, we have fixed it in this version, but like, do they have it? Maybe it's another one, another bug, something else. So yeah, versioning, very important thing. We have 3 versions, major changes that might be breaking changes. So they might break some functionality, for sure not the big one. For example, we had some changes in scripting that we changed one function. And as always, as we're not collecting a lot of, like, we're not collecting any data with telemetry from users. We have some like bug reports and forum and Telegram messages where people complain and we know that they use. And then we think, okay, we can change this thing and like most of the users won't be touched, like no one uses it. And then, yeah, a lot of complaints come. So there might be some major changes that will break your system a bit, but we always mention it in the notes. So minor, it's smaller changes, new features, but we might break in the minors compatibility level between server and client. So like if you will, like we have special like this numbering that you can't connect with inappropriate versions between server and client. But if you like will try, then something won't work or something will like break if we wouldn't like make these changes in the version, for example. So yeah, that's why this means if you update your server, you should also update your client. Next part is patch version. Usually it's bug fixes. It might be some small improvements that we are for sure know that they won't break the system. For example, some new function in an XSL, for example, some new mass function. We know that it like won't break the system. So yeah, all components with the same major and minor are compatible. Also about the agent, we have backward compatibility with all agents because we, for example, already for a long time not building agents for Windows 7, but there's a lot of people that use Windows 7 and use old agents and they work perfectly well. Maybe they don't have the latest and greatest functionality, but like they have most of it and people are happy. So also, we usually don't say that we have compatibility between newer agent and older server, but at the end, we have some clients that have two servers and agents, and the servers collect from those agents information, and they update one server and update agents, do not update another server, because like at least one of them should be up and running. They should be sure about it. So they test only on like half of the infrastructure. And this is how we get new agents, old server. And still, usually we are like, it works. And if it doesn't work, they complain and we fix. So about the development process. One thing, especially in COVID times, that we like started struggling with is to be up to date with the team. We are not a big team, we are a pretty small team, but still we have developers, we have a support team. So we have created calls 3 times a week for developers and support team to share features and support team struggles. So basically, one of our problems that we write the code and functionality much faster than we write documentation. And not every, like, it might be much faster if the developer by himself will explain to the support team the new functionality. And support team really helps. Sometimes they ask questions we didn't thought about, and then we improve our new features. So yes, and for developers, it's important to have this up-to-date meetings, maybe about new C++ 11 features that we started using. some improvements that we made, some changes. As I said about versioning, update changelog. Like versioning is one part. Another part is changelog that should exist. You should know what and when was fixed, what features were introduced when, because as our product is pretty old, sometimes people come with really old versions, just don't want to update them. And we should be able to trace back, like if something they complain about is something that we already fixed and to which version they want to upgrade. So also update issue tracker with solutions, with commands in issue tracker. It's like open, you can create account there and you can propose to us some features that you want. And it's really good that you have the vision of your product and not just implementing all the stuff that is suggested, because like I haven't seen such an application. I've seen a lot of such games. When you implement all the stuff without global vision, game is not playable anymore, because like it's like 10 different people had different visions. So that's why we implement the feature that is requested a lot, but it might be different in implementation, in the idea. For example, a lot of times people ask us like, implement this thing. And we start to ask them like, why do you want this? What is your use case? And a lot of times we either can say that, okay, it's already implemented, you are doing it just wrong, like do it this way and it will work. And another situation, we just think about our infrastructure and know that there is a better way to implement it. So yeah, it's always better to make few notes about how it is done, how you can use it in your issue tracker. And we use a lot Telegram. We use a lot Telegram chats, group chats, where we post some issues that we found, that we divide work between each other. And yeah, all the calls are also happening there. You want to add something?
Yeah. So before we get to this code security, I want to go a little bit back. With this, that's called goals, yeah. But I want to talk a little bit about the development stack that was chosen. It wasn't mentioned anywhere, but the main language of the development is C++. And the product is old, so we started in 2003, and it was a really logical solution, logical decision at that time to go with C++ because of those goals. We want low profile, high performance something. And C and C++ gives you a lot of control on what you're doing. It may not be a good decision today, not that C++ got worse, but you may not be so much constrained about the resources you have. Maybe something more high level could be better in terms of like speed and simplicity of development. But we have the system already in C++, so we don't plan to switch. We have a lot of put a lot of efforts and get a lot of expertise from this development. We use Java for user interface development. Again, it's not a logical choice today. but back in the days, it was good enough. And it's mostly because our team, I would say, is more backend oriented team. So we are not good at web development, but development in Java is much easier for us than, for example, in JavaScript and web environment. But we will get there one day anyway. But for now, we use this Java as a GUI language, language for GUI development. And from this comes this code security. So why we, because the C++ and the C, they give you performance with a trade-off of potential of easily easy making of the bugs that's hard to detect or hard to find. So you need more tools to fight this. So we use different tools and techniques to work with this. One is static analyzers of the code. So we run static analyzers from time to time. We use Splunk, and sometimes it finds really interesting bugs. It has a lot of false positives, but still you can find useful information inside, and sometimes it's really, really helpful. We use memory analyzers. We used to use Valgrind, but now we almost exclusively switched to memory analyzer built into GCC compiler. It's they call it Sanitizer, and they provide checks for memory leaks, for out-of-bound access, etc. So basically, we do all the development builds and all the automated test builds with GCC Sanitizer turned on, and sometimes it's really, really good tool to find bugs before they get to actual release. And the next point is for any language, is valid for any language, update your dependencies, update dependency libraries. And we try to use as little as possible dependencies, because the more dependencies you have, the more potential problems you have. On the other side, the less you have to develop yourself. So it's always, we always try to validate. Of course, we will not re-implement SSL, yeah. So of course we use OpenSSL library. We have to update it because they find security issues all the time in OpenSSL. Sometimes you have to update quite fast. And we try to use available language mechanisms and development patterns that can reduce error possibilities. So, for example, some time ago, we switched to smart pointers in C++, which really helps you to avoid memory leaks and sometimes also resource leaks. We start using the builder pattern. I think the next slide. This is a good slide. So the code before and the code after. So it does absolutely the same, but after refactoring, it's much cleaner and much. You have to turn on the microphone.
Yeah, this one was before, and you can't see here, but this part was in the beginning of the file, and this was somewhere in the middle, and the last part is the after. And yeah, Victor, you maybe can describe a bit more what does this?
It's not actually relevant, but you see that it's much simpler afterwards, and it gives you more idea what's going on. So basically, if you even not that much familiar with the code, you see it, okay, we're adding some parameters to something, and then we finally end it with like a post call. And before that, it was the function with a variable, variadic arguments, and some magic format strings, etc.
But
So
I think it's really relevant because like a lot of people end up with that, as I said, we have a lot of events and first of all, we had just events with parameters that were referenced as 1, 2, 3, 4. And then we found that, okay, we have event that threshold is active and then event that threshold is not active. And they both have this parameter, what was the real value of the threshold. And it is in a different positions and users mix it all the time. So for sure, for user friendly, it will be much easier if we will use those names, like we will name those parameters and users can reference them by names. And then afterwards, we also decided that event should have tags. And then we have a lot of code. Some of it has these names, some of it doesn't have these names, some of it has tags, some of it doesn't have tags. We have about, I don't know, 10 different functions post-event. Post-event with data collection item, without, that is just system events and stuff like that. So we have a lot of it, and we have just some parameters that we provide just one by one. And like if you mix some order, here we have what types of the events we have, and somewhere at the start of the file we have the information, the names of them. So you can imagine like you do something wrong and like nothing works and server even crashes because yeah, like and that's why this one not even looks simpler. You won't have a lot of errors because the name is connected with real variable that provides this value. And also we, in the function itself, we know what value do we provide, and we don't need to provide the data with the hands, like what the data was provided. So, yeah.
this is just a nice picture that summarize it. Okay, and now it's back to Tanya, because
Yeah.
that's what she does a lot, all the automation on builds and testing.
Yeah, I wanted to mention one more thing. Yeah, okay, about updating dependencies. One of the things that we found that works really good is that you should update, or at least you should test your dependencies automatically. So we have Windows build that checks if we're packing inside latest libSSL library, and if there is the latest libSSL and we are packing not the latest, we just fail the build. Like at least it's half automatically, at least we won't provide old version to the client. We, okay, for sure should go and update it manually, but yeah. So about our development process, make it work, make it good. Philip, can you also give me a charger? Sorry. So what I mean about this, we're developing a lot of functionality, and this functionality we develop in iterations. So first of all, usually we have some proof of the concept. It might be just a small code that even that is not connected with our code of the server or of the agent. For example, here, yeah, we were like, it was like first tests of if we can catch all the data that is required. So then we populate code step by step, one by one, because even sometimes we have really great, beautiful vision of how it should work in ideal world, but we don't have resources and we don't have time to implement all this. But still, it's good to think of it and to implement the code that afterwards you can extend, afterwards you can populate, you can think of how to adjust it. But usually we define some kind of the scope that we will implement, and then we will see. And as we implementing sometimes features that we have thought about ourselves. So it's not the request from the client, it's not the request from the end user. We just thought that, oh, this might be great. We sometimes help people with configuration and we see their struggles and we think, oh, yeah, this will be good. But still, you don't want to put all the efforts there because it's not a request. It's your assumptions that something will be worse, something will work good. And we still have those we release some part, we check if people use it. Usually we see if people use it by the questions how to do something or by bug reports. So yeah, and I've seen a lot of companies that were not giving their products live because they were thinking, oh, we should do this one more part and then we will release and this one more part and this is something better and it's the thing that we don't have that competitors have, so we should wait a bit and develop one more, and like you never go to the public. And once you go to the public and have some feedback, it's already like not too late, but you should change really a lot of things from this feedback that you could, they could be omitted if you started earlier. So yeah, it's always good to get feedbacks, to make it in small chunks and to test it on real system. Also, as I said, for example, caching stuff comes, it's not like from the start we think that, yeah, we should cache this data. Usually it's like we develop some prototypes, we see that, okay, the system doesn't work really good, it doesn't have its own caching, or like we're requesting a lot of data because it's some performance data that should be like requested every second. So yeah, we like gradually we go through adding more features and adding more functionality. So yeah, about refactoring a lot. Yes, it's one of the things that when you add new features, you might need to refactor your code when you have a really old product. Sometimes you even like spend a month that doesn't bring any new functionality to user. It's really frustrating that you work just whole month for just refactoring, and then it's like we're doing release, and in changelog it's just a few features, and it might be really upsetting, but at the end, every new implementation, every new feature that you do, you just feel like it takes you much less time. The error, the bug numbers going down because you changed something. And one other refactoring that we were doing was connected with C++ versions. Before we were supporting hooks, IX, and other systems, which C++ compilers are not like are pretty old and they do not support C++17. For now, we should stick to C++11. It's still improvement for us because like, I don't know, 5 years ago, we were not able to use it, and now we're able to use it. And it really decrease memory leaking, pointer allocation, deallocation, and stuff like that. So yeah, it might be frustrating, but you should think of the time that you should invest in this. Automation is our everything. Also test automation. We have some unit testing. As C is low level, we found that different compilers give different warnings. And we try to find the really right compiler that you can compile with, and it will provide you all the information with like incorrect usage, or like you try to put some data into buffer that is too small and stuff like that, but we really don't have it. Windows compiler gives you one exceptions, Linux compilers give you another one, and different Linuxes give you different exceptions. Also, when you build, had the issue that we have created tests and everything works on my computer, everything works on like my colleague computers, but then we build everything on the platform x86. Yeah, nothing works because registry, because like it's smaller and the data goes a bit differently and the test fails. So yeah, we find it really useful to, as we are a multi-platform company, to test it on different platforms. We have some integration testing that are done with Java, and they test our Java API. They go through the whole system. They start like from the Java API on which our clients, this rich client and web client, are based. Go through the server, sometimes load data from the database. Sometimes they request some data from the agent. So it's truly integration things. So yes, continuous integration and test while documenting functionality. About continuous integration, I will show next slide. And about testing, I find it really easy and useful to like test functionality while you document, because while I develop, I see it from the developer perspective. But when I start to write the documentation, I start to think from the another perspective, from the perspective of user who will use it. And then you are capable of doing stuff that you won't ever think of while you are a developer. So yeah, it's one of our requirements to change the shoes a lot, to change the shoes between like C++ and Java. So we write in both languages and to test the stuff, to write the tests, to write the code. Continuous integration. So yeah, we use Jenkins. We use a bit Drone. I personally was configuring Jenkins because I knew it at the time when I was doing it. Maybe it's not the best solution. We have Alex, who knows like latest and greatest. For me, it was just the fastest way. I do not regretted, because now we have about, as I said, I think more than 20 systems on which we are doing builds. So we have one build that is built after each commit. We have some builds that are built once per day. For example, all this, all specific builds, we decided that it's okay to have them once per day. If something is broken, like it's okay, we will fix it next day. At least like almost all developers work on Linux, Ubuntu-based OS. So mainly, if you haven't, if you didn't broke the main builds, most probably on developers' machines, it will work. So yeah, might be okay. And yes, we automated. So all the unit tests are running on all those systems. We have a test for the database, as we are upgrading database, and we have two databases. We have server database and we have agent database, and we can upgrade database or we can install database from the scratch. So we are testing all the time both options, because sometimes you write upgrade procedure and you just miss SQL file to be updated with the new field. And yeah, that's like bummer. So we're testing this stuff. We're testing some packing stuff, because yeah, it also was, we were breaking it a lot. So mainly we test that we were breaking a lot. For example, we have non-Unicode build. And usually every developer has Unicode built on their laptop. So we have a test that runs every day about non-Unicode build. And yeah, we were checking this as well. Yeah, bug is part of developer's life. As I said, like sometimes, if you don't have bugs, your application is not used. Like you should be used to it. And you should think about it in a positive way. So yeah, you should make clear users where to report bugs. And we found that like we all are people and we're lazy, and we might be self-doubt. And now I think, especially on GitHub issues, it's getting better. But sometimes person just doesn't know if it's an issue or it's his problem configuration. So for the end user, sometimes it's much easier to write on a forum post or write in the Telegram. We have Telegram support channels where people write and ask questions, and mainly, yeah, it's not bugs. But sometimes it's really bug, and it's much easier for the end user just to ask like if I'm doing everything right, and then to then developers or support team create issues or notify us about those issues. But yeah, really important life cycle. Yeah, one of the things that we faced that you should not release on the 31st of December. Yeah, like we thought that if we will release on the 31st of December, like who will install it? Everyone is celebrating New Year. No one is interested in like new version of open source monitoring tool. No, like if there are people to release on this date, there are people to install it on this date. And the 1st of January was a patch release. Yeah, because there were some bugs, and there were like we were required to fix some stuff. Yeah, and now we're trying not to release on Friday, and usually it's like we start on Monday, and it's like, no. Now on like Tuesday or Wednesday, we will have patch release, then collect all the bugs that we need to implement and that we want to implement. And there is always the last features like, let's do this one. this one will be the last one, and then it comes till the Friday, and we decide like, no, we don't want to make patch releases, because sometimes it's not, we make patch releases not because of the bug, but because we have missed some, like, I don't know, new sub-agent that is not included into Windows build, or that packages were built incorrectly in some way. So yeah, think of when you release. If you are crazy enough to release in the 31st of December, then there are another people crazy enough to install it the same day. Efficiency and automation. So it's another thing, is like when you have really small team, you should automate a lot. Especially for us, it was build automation, because when I came 10 years ago in the company, there were no build automations, and build was taking, and there was no depths, and there was no dep repository. It was just some binary release, and it was taking 1 or 1.5 day of developer time to make a release. So it might be a big automations that really help you. We still are not, I can't say that we are fully continuous integration stuff, that we just press one button and release is fully made, but most of the things are done automatically with Jenkins. So we have automated documentation builds. We have some enterprise builds that can be done for the clients with one click. So now it doesn't require developers time to provide new build to the client. Like any person can update client configuration file and make a release. And also we have some like this release tab that has some stuff that we release. Yeah. So mainly, yeah. Still, like some of the things you just don't want to automate. For example, some, I don't know, security, signing, signature generation, maybe even like putting out to the world the release. Maybe you first like still should check some stuff by yourself. Yeah, as you can see about the tests, we have this test and test table. It's exactly the separation between master, where we develop a major release, and some stable branches, where we develop patch releases or minor releases. And usually we have a main branch where goes all the code. Usually it shouldn't be broken, because developers start from there to develop their features. And but it might not be as good, like it shouldn't be as good as stable branch, because yeah, there goes only patch releases. We make some manual testings before releasing from the master branch, and we document some stuff, and we test while documenting those stuff. One of the things, if you will use Jenkins, that I found really useful, we use a lot of, like now it's fancy to use these pipelines. We use them a bit. I still use the old school SSH commands or some Jenkins plugins. But I found it really useful to make templates, because I have like plenty of builds in the test that are just exactly the same. You should run make install, you should run configure, you should run other stuff. So we make single template that is configurable. You configure it with different options, like to which database this test environment should connect, which credential it has. On some systems, we have Oracle, with which we're like building drivers. On some servers, we might have MySQL, on others, MariaDB, and so on and so forth. So we provide some configuration variables, but mainly, like, as always, I was required to refactor all this stuff because first we had like few systems, then we had 4 or 5 of them, and then something was required to be changed in the build procedure. And then you are required to go hand by hand and change each part. And at that time, I just made a refactoring, made a template task that I'm running from the other tasks, and it really helped. And about small automations, there really can be like a lot of different small things that you can adjust really daily that will increase your productivity. For example, we have watch and refresh script in some of our documentation repositories. There you can, you run the script, you change the documentation, and the script automatically detects if the documentation was changed and rebuilds it. So when you change the documentation, you don't need to do 3 steps, like change the documentation, make a build, check, for example, in web browser. You just change, and then you refresh the web browser, and you see the result. So it's really a little thing, but it can really increase your work productivity. Also, we have automated test of that package deployment, and we have also created the script for diagnostic information collection by end users. So when you have some strange problems that person just complains that I can't create new object or I can't do anything, but the system itself works and you can't understand what the problem. We just say to them, you should install GDB and just run the script. The script itself collects information about threats. It collects some information internal about threats, and then like it's not the requirement of the support person to guide through like run this command and that command. And sometimes people just send us the screenshots of the results, like which are really hard to analyze, really. And like sometimes it's like 5 screenshots of the views, and I no idea why people do this. So we have created the script that is our life and is life of the end users. Yeah. Do you want to add something? Next slide. Okay, community engagement. Yep. Okay.
Okay, so I will take over on this. So as we are open source product, so community is important part of the product, and it gives us ideas what to implement, and most of the product is based on the feedback, actually. Yeah, it was started from my own experience. It was started from what I have seen in other products at that time, and what I think could be useful for network engineers and system administrators. But after that, it's mostly community driven in many areas. Community is a really good resource for testing, because there are people that are brave enough to just install a new release, especially a new major release on the day of release, Um, and they got all kind of strange bugs that we didn't catch. Community provides you like a huge diversity of hardware to test system on, because you cannot have everything in your office, and people around the world has all sort of strange devices that they try to connect, and very interesting scenarios of the system usage. So it's really invaluable, and it helps us survive as a team, because we make money on our commercial customers that pay for support, and in many cases they don't really want to upgrade on the next day after the release. They want it to be tested, etc. And the open source community actually helps us with with that testing. So after some point, after major release, we have stable product tested, running in multiple environments. We know, okay, we have kind of stable checkpoint, and commercial customers upgrade afterwards. Sometimes we get just interesting solutions back from the community, like how we use the system, and it's maybe not that much helpful for us as a developers, but it helps other users of the system, and it helps growing the community. So if the community that is giving back, it's actually growing faster. Code contributions we get some from time to time, and this is tricky. On one side, it's great to get patches, some maybe new features, but we still need to recheck and retest it, because sometimes people don't write code on the necessary level, so it may contain bugs, it may break something within the system that works for them in their specific environment, but will break something in other environment. So we welcome code contributions, but it's on the other side, it's additional load on our team, because we still have to integrate them properly and retest them. But it always, anyway, it's always nice to get something, because it means that somebody use the product, actually likes it enough to dig into it, figure out how to change things and improve it maybe. So I think that's it.
I cannot about contributions.
Very quickly.
Yeah. The things that we add, the things that we found that like I was thinking that we're going to GitHub. Before that, we for sure had open source and had repository. It was not GitHub. We went to GitHub, and I thought, oh, now we are going to GitHub, and everyone will contribute. No. It's hard for people. Sometimes it's much easier for them to give you the file with a patch. Recently, we got a few zip files with modified code, and like people just ask like if we can add this. Also, sometimes people just like write the command that please change this line. It will fix that and that, and it might be much easier for them. Yeah, and you like truly never know how people will use your product, and it's really fun and exciting when you get those feedbacks. Yeah.
Wow, great. Thank you so much, Tatiana and Victor, for sharing your knowledge, your challenges. So I've got a lot of insights. Thank you so much. I think all of us uh, got them. So if you have any questions, we have something like 10
10
minutes left only, but probably after lunch we may proceed with this.
If anyone wants to talk with us, I'm here. It's me. My name is Tatiana. Yes, I haven't introduced maybe. Yeah, I will be happy to discuss anything like about NetXMS. I don't know. We're from Latvia. About Latvia. So yeah, just come and have a chat. I will be happy.
Wow. Thank you so much. Yeah, so as I've said, our speakers do this on a voluntary basis. So, I mean, they invested their time and money to come and share their knowledge and also to upgrade us. Thank you once again for that. And yeah, so in case you have some questions, probably. Okay, okay.
Yeah, thank you so much again for sharing all of this and very diverse and deep information on a lot of topics. And I would particularly ask about the refactoring you mentioned. So, I mean, that probably might be not a secret, but sometimes it's difficult to bring the value from those refactoring to, let's say, upper management. I mean, maybe it's not your case, but since you are a small team and you're probably all on the same page with that. But can you recommend any like metrics you would recommend to track and to transform this refactoring and readability thingy into some value to the business and to the upper management? Or, Thank you.
Yeah, so it's uh, it's hard to quantify it. It's there is a term called technical debt. Yeah, you maybe heard. So at some point, it just becomes maybe unmanageable. Yeah. So when you realize that any change take long time and maybe breaks the stability of the system, that's the time for to think that maybe we have to rewrite parts of the system to do some refactoring, because our continuous work just became ineffective. Yeah, but it's really hard to quantify. You cannot say we will spend a month on the refactoring, and after that the new features will be added two times faster. Yeah, of course you cannot say that.
You still can say that, okay, you see, we all the time we have bugs popping out in this exactly field, and like it's because it's really old code and we should rewrite it, and we'll have less issues, and you can count that, okay, we have spent a month for issue solving for last half of year. If we will spend like 2 weeks in refactoring, then like next half of the year, it will be like 1 month less work, like maybe things like this. But yeah, as Victor said, it's I know it's really hard for the management. Maybe I know some teams do like that. They when the manager comes and ask how much time will it take, they just put inside of this time, inside of the time of development, refactoring, at least like some parts. Usually when you can't, and usually you can't really sit and half of the month refactor the code. Management doesn't understand this type of stuff. But yeah, you need to gradually, with some steps, change some stuff. Yeah, sometimes it's not possible. Sometimes it's required 2 weeks to just sit and change all the stuff. But then, yeah, prove it with the bugs. But yeah.
No, I know that it's hard topic for a lot of if you have a bigger team and I don't know, non-technical management, it's really hard time to explain why you have to do kind of nothing, and it's a lot of articles written on how to do refactoring, how to
How to
say
present
to
it?
your man, how to say,
Yeah.
how to present it to your management. Yeah, we don't have this problem, yeah, because we're a small team and we are a technical team. But what I see from my experience, sometimes also developers could be a bit carried away with like, let's make the code even better without, and some reasoning is lost actually. So you have to balance practicality with let's do it in a better way. Sometimes you just have to stop and say, okay, we have this code base, we can, it's at the point where we can live with it. It's like good enough
Yeah,
to,
good,
to work.
good enough. Is
You
the
don't,
word.
you cannot, because it's kind of infinite process. You can always do some better,
Yeah.
better. You have to stop somewhere. Yeah. But it's really complex.
Hi, I'm curious about your development to deployment workflow. So I've checked your GitHub. I haven't seen any, let's say, internal discussions. So I'm curious, where do you do these internal discussions? How do you upload? Do you upload it in GitHub? And how does, let's say, contributions to GitHub go back to the
Mhm.
internal repository if you do have?
Yeah. Okay. So GitHub is our primary repository. So we actually commit to GitHub. You can see commits. Internal discussions, we use Telegram instant messenger application. So we have group chats in Telegram, and we actually use it a lot. Also, we just met in our office in person quite often. From external side, from outside, there is bug tracker, which is not on GitHub. It's self-hosted bug tracker. Sometimes people report issues on GitHub, but most of the issues in the bug tracker, it's reachable from our website, and it's free to register, so everybody can register, report bugs there. Some people really do pull requests on GitHub. You can check the history of the pull requests. So there are some, we evaluate them and integrate.
How about, let's say, internal code review? So do you do pull requests as well, or do you just merge to master?
We don't do pull requests. So normally, um, it's just a separate branch. So when it's ready for review, somebody, usually me, do a review and just comment, because you have this comment feature on commit in GitHub. So I just add comments. It's fixed. When it's okay, the branch is merged into the main branch.
Sometimes we push to the main branch if it's small changes and we're certain about them.
Yeah, yeah. So again, small small team.
Yeah,
So
small team,
we
but,
can.
yeah, we do not release master. We first test it and check it, and we have a lot of tests. Yeah.
Yeah, and before release, or when we have a really major feature integrated into main branch, I usually ask Philip to just play with it and
And-
test it a bit at least. So we got some also manual testing.
And we don't say that it's best practices. It's totally not best practices. It's just like something that worked for us. And yeah.
So I have a question concerning tests. So you built many different releases on the different Linuxes, and you also claim that you have some backward compatibility between different versions.
Mhm.
How this is covered with tests?
Okay, so the build, we built on different systems. It's automated. Part of when build completes, so we know that it compiles. We run integration tests. We run unit tests on that system. So on each system we have unit tests. If unit tests fail, we know that something is really broken. And we consider that if system pass unit tests, then it will work. And integration tests we run only on one system. Yeah, so we have one system where we run also integration tests, and integration tests the like higher level logic of the system. It simulates user action to some degree. So like we create new object, set up data collection, check that data is collected, etc.
And as we use Power Self-Monitoring, we test while using. Each developer is required to test the stuff. And about this backwards compatibility, usually we think about it, we implement it, and then we have like latest and greatest on our laptop, and we have somewhere already installed old agent to which we're connecting and like checking that, because we have really a huge infrastructure for the tests, and they're big zoo where we can test all the stuff.
Hi, just one last question maybe. So one of the biggest problems we have in science, well, in software development and science, is we almost never write documentation. This is a huge problem. So it's very interesting what you said now, where you try to put your testing in a documentation loop, right? So could you say something about how you make sure that you include the documentation in the testing? So we can test, but we don't do documentation. So we can't do the tests the way the end user would see, right? We can't test the functionality from the end user's perspective. How do you ensure that you do this? Do you have an automatic way of doing testing while documenting, or how do you ensure this?
It's just like, yeah.
It's not automatic.
Yeah, it's not automatic. It's just like when you, as we have a lot of visual stuff, when you write documentation, you should make a lot of screenshots and you should configure a lot of stuff by yourself. And at the end, you are just we just play. I just play with the system, or my colleagues play with the system and think of the stuff that can be done, and think of what the questions. At the end, it's just error, failure trail that you go through. And sometimes customers come and say that like totally not understandable documentation, and they come just with the sentence, and it's just beautiful sentence, and you just put it to the documentation and say big thank yous to those guys, because they are just capable to say it's like really clear. We have the same struggle with documentation, that we write code much faster, but we also think that like if we won't document, no one will use it. So it's a trade-off.
Yeah,
Okay.
but again, it's not automated. It's just a procedure that usually it's Philip, sometimes Tanya, that configure the system while documenting. So basically, you do what you document.
Yeah.
And sometimes you catch that it's not doing what it's supposed to do, what you are going to document. So it's integrated in that sense.
Okay, so sorry, I will
Microphone,
pass.
microphone.
Hi, my name is Alex. I'm also from the team. And I want to add that you can actually automate documentation to some extent, at least what we do with scripting language. We have a couple of scripts which extract like all the functions, all the constants from the code, and then another script basically parse the existing documentation to make sure that at least we have a list of all the functions, all the constants, it's all in documentation. And it also, it does both ways. So we check that something added, which already removed from the code, or something added new. So this way, at least we can know that CI will detect if someone added like a new constant and it's not documented. So
And I
I
think
guess that's the only automated part in documentation for now. But
we also can automate data dictionary, but I think not yet. Yeah, so it's.
Okay, so we probably will have only two more questions. So one online and one offline. And yeah.
Yeah, let's start with online one. And before going that, just a small comment. Well, actually, Olga gave a talk at last Scale conference. Scale stands for South California Linux Expo, on building documentation pipelines and how to engage with the community through a communication. And yeah, because actually your documentation is communication to your community. And so the question online we have, are there any some processes or rules that you found work really well for open source projects that you would recommend using? So for example, some projects require that every bug must be reported on and reproduced in as a new test case. So can you?
I found that it's really useful not to limit users because as I said, we thought that we will go to GitHub and they will send us a lot of pull requests. Still, people, it's hard for them to make pull requests. It's much easier to send just updated version of the file, and it's okay. It's good for them to have different options. Then they have they can contribute more. It's, I think, the only main thing about working with the people. And people are lazy, make as less steps as possible for those kind of tasks you want them to do. So
Yeah, for a bit about bug reporting, sometimes it's really hard in case of our product to create a reproducible test because it may be dependent on specific version of the firmware, for example, or specific vendor that we do not have. So we collect as much information as possible from the user, but we do not require make it reproducible in our lab. And so no particular requirements.
Hi, my name is Dina. I'm from Argonne National Lab. So first I wanted to make a comment about C++. I think it's great that you use it because it's less changeable language. And another question is, what if a user needs to reinstall this whole server or the agent? Is it possible to have like a backup or like kind of single file, which is like saving all of the settings, stacks and everything? And is it easy would be to kind of take only one file and run your system from that single file and to install and configure everything? Or
Okay, so server keeps all of the configurations along with collected data in a SQL database. So you can use a normal database backup restore functionality. If we talk about Postgres, for example, you have the Postgres dump utility base, which actually produces a single file with everything. You can import this file into another Postgres instance, install the server binaries, and it will run. We also have our own internal functions for exporting, importing, and migrating database between actual databases. So yes.
on the file system, we have one file that configures the server, where to write the log rotation stuff, some other adjustments, and how to connect to the database. There are a few other features. I think images are, no, already not. Yeah, so like mainly it's like one file of the configuration that you just can recreate. All the data is in the database. So yeah.
Yeah, I'm sorry, but probably as for now, we have to pause for lunch. Yeah, because everything is there and waiting us.
Okay.
Yeah, so thank you very much for your knowledge sharing, for sharing challenges with us. And I would like also thank our participants, offline and online participants as well. There were quite a lot of them. And if you have any questions, I think we may proceed after lunch, but probably not in Zoom. So I will later send an email, probably, if you...
We will be happy to answer all the questions.
Yeah, so probably if someone from our Zoom will have some questions to ask, I will then pass them to you. Okay, thank you very much once
you.
again.
Yeah, thank
Yeah.
you, everyone.
Yeah, it was amazing. Thank you.